Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will learn the topic with the title Supply and Demand Analysis. This is section 1.5 in your textbook in page number 67. Before we start with this section, let me summarize what we learned in the previous two sections. In fact, in section 1.3, we did learn the linear equations and its graph. In section 1.4, we did learn algebraic solution of simultaneous linear equations. As an application on these topics, we are going to study today the supply and demand analysis. Actually, these slides provided by our colleague Abdul Karim from Math Department. The objectives of this lesson are analyzing the demand function and supply function. So there will be two functions, the demand and supply functions. And number two, find the price and the quantity at market equilibrium. So let's begin with the demand function. Demand function is defined as a mathematical relation between the quantity of a good demanded by consumers and its price. So it's a relation between two quantities. It's a linear relation, similar to the linear relation which we learned in section 1.3 between x and y. So here we have two variables, two quantities. We call them the demanded quantity and the price of the quantity. That's why we call it demand function. It's the relation between the quantity of food demanded by consumers and its price. Demand function is given by this formula. P equals A times QD plus B. So P here is the price of the good, and QD is the quantity of this good, and the quantity demanded by the consumers. A and B in the above relation are real numbers, where A is less than 0 and B is larger than 0. So A will be a negative number, B will be a positive number. Which means that as the price decreases, the quantity demanded increases. And this function is called a decreasing function. So when P is decreasing, Q is increasing. As an example on this demand function, you can see this one. You can see, let me use the laser point here. You can see P equals minus 2Q plus 25. So Q here is QD, in fact, is the demand function. You can see the numbers here. A is negative and B is a positive number. So we will get a decreasing function. Another example is P equals minus 5 QD plus 60. And one more example is P equals minus Q plus 44. So you can see in all these examples, the real number here, minus 2, minus 5, minus 1. These are the coefficients of Q. In fact, this is QD, the demand function, or the demand quantity. So these are negative numbers. The other numbers are positive, so this is a decreasing function. Let's continue. You can see in this graph also, this graph illustrates the relation between the price and the quantity demanded. You can see it's a decreasing function. You can see here the line is going down. Okay. So as the price is going down, the quantity demanded will increase. This is from the economic theory. Let's have this example. Example number 1. The demand function of a good is given as P equals minus 2QD plus 60. Again, this is a negative number. So what we need to do here is, number 1, graph this function. Number 2, calculate the value of P, the price, if QD equals 9. And number 3, calculate the value of QD, the quantity demanded, if the price P equals to 10. Okay? Let's see the solution of this example. Now, to sketch the graph, you need to refer to what you learned in section 1.3, in fact. If you remember, you need to generate the table for X and Y, but now we call them Q, D, and P, and you have to assume some values for QD, 2 values enough for QD, and you calculate the corresponding values of P, you create the table, and then you use the graph table to graph the function, the previous function in this example. So you will get this line, this graph. Okay, so this is the decreasing function graph. For number 2, we need to calculate the value of P if QD equals 9. So what you need to do is just substitute the value of QD, which is here 9, in the given demand function, this function. So if we substitute QD by 9 and you do this arithmetic calculation, you will get the price equals to 42. Now in number 3, we need to calculate the value of QD if P equals to 10. Again, we need to substitute P equals 10 in the given demand function in this function, and then we will have the following. If we substitute P by 10, then 10 equals minus 2QD plus 60. Rearrange the equation, you will get QD as 25. So this is the answer. So the quantity demand will be 25 if the price is 10. And number 2, the price will be 42 if the quantity demanded is 9. For the sake of comparison, you can see when QD here is 9, the price was 42. When the price is reduced to 10, QD is increased to 25. That's why if the price is reduced, the quantity demanded will increase. So this is a decreasing function. Okay? Let's have another example. The demand function of a good is given as P equals minus 3QD plus 45. We need to calculate the value of P if QD equals 5. And we need to calculate the value of QD if P equals 24. I will leave that example for you so you can try it. Let's move to the other function, which we call it the supply function. The supply function is defined as a relation between the quantity of a supplied good and its price. So the supplied good means the good is supplied by the salesman. So this is the formula for the supply function. It looks like the demand function, except that here instead of QD we will have QS. We still have two real numbers, A and B. So again, P is the price and the QS is the quantity supplied. A and B are real numbers where A is larger than B and A is larger than 0 and B is larger also than 0. So both A and B are greater than 0. Both of them are positive numbers. So as the price increases, the quantity supplied also increases, and this kind of function is called an increasing function. You can see here, if P is going up, QS is going up. So as examples on these supply functions, you can see here these are three examples. P equals 2Q plus 12. This should be QS as well. And P equals 5Q plus 44. P equals Q plus 25. So you can see here as the as the price increases, the quantity is also increases. As the price is decreasing, the quantity is decreasing. So this kind of relation is called an increasing function. Okay. So let's move to equilibrium point. So when sketching demand curve and supply curve at the same graph paper, we will find what we call the intersection point between the two graphs. So what you see here is the graph of the supply curve for the supply function, and the red colored line, which is the demand curve for the demand function. This is the intersection point, is the equilibrium point, where at this point we have the quantity supplied equals to the quantity demanded. Hence the price of the quantity supplied equals to the price of the quantity demanded. So at equilibrium, we will have QD equals QS equals QE. E stands for equilibrium here. So always remember this condition. At market equilibrium, QD equals QS equals Q. So if we have this example, for a certain good, the demand and supply functions are given by these two equations. You can see the first equation is for the demand function because of QD. The second equation is for the supply function because of QS. So we need to calculate the quantity of this good and its price at equilibrium point. So at equilibrium, QD equals QS equals Q. This is very important. Two lines to be written when you solve any question, because this will indicate that you understand the meaning of equilibrium. So under this condition, QD equals QS equals Q. The right side of the two equations here will be equivalent. Why? Because the left sides of the two equations are equivalent, P and P. So the right sides of the two equations are also equivalent. So we will write here the right sides of both equations. And then if we manipulate this equation to find the value of a Q, and you should be familiar with this kind of manipulation because you learned this earlier, then you find a solution for this linear equation with one variable. You can just rearrange the terms and isolate Q on one side, and then you will find Q equals to 10. So this is the value of Q, the value of the quantity. Now we need to find the price also. So if we substitute this value in one of these two equations, we can calculate P. So let's choose the first equation for substitution, and I'm going to use this equation. I wrote it here and substitute the Q by 10, and then we will find that P equals 30. So at equilibrium, the Q equals 10 and P equals 30, and this is the answer for this example. Now let's move to the second example. It will be almost the same as example 1. The difference is we have two equations, demand and supply equations with two values of A's and B's. And what we need to calculate here, the quantity and the price at equilibrium. So I will leave this example to you. You can solve at home. And if you need any question about this, then we can discuss it during our live session. I think this will be the end of the presentation. I would like to thank you very much, and I will see you during the live session, inshallah, during the class time. Okay, bye-bye.